Welcome to What Is. Today, we're going to talk about the fact that you, me, your dog, the Earth, the Sun, and that weird leftovers container in the back of your fridge are all technically irrelevant. Well, not irrelevant to us, but in the grand scheme of the universe. We're basically the foam on top of a very large, very mysterious latte. For centuries, humans assumed that what we saw was what we got. Stars, planets, dust. If it glowed, reflected light, or blocked light, it existed. We felt pretty good about ourselves. We mapped the stars. We sent robots to Mars. We took a picture of a black hole. We thought we had the inventory list of the universe pretty much handled. And then we did the math. And the math basically told us, hey, you know all that stuff you've been studying. The entire periodic table, that's only about 5% of what's actually out there. Imagine going to a grocery store, filling a cart with 100 items, getting to the checkout, and the clerk tells you that you only have 5 items. You'd be confused. You'd be annoyed. You'd probably ask to speak to the manager of physics. So, what is the other 95%? Well, about 68% is something called dark energy, which is a headache for another day. But the other 27%? That's dark matter. And today, we're going to figure out why the universe is haunted by stuff we can't see as we ask, what is dark matter, and why can't we see most of the universe? To understand why we think dark matter exists, we have to talk about how things move. Back in the 1930s, a Swiss astronomer named Fritz Zwicky was looking at the Coma cluster of galaxies. Zwicky calculated how much mass was in those galaxies based on the light they emitted. Then he looked at how fast they were moving. According to the laws of gravity, they were moving way too fast. Based on the visible matter, these galaxies should have gone flying off into the void like a carousel spinning at Mach 10. But they weren't. They were staying together. Zwicky concluded there must be some dunkel materie, dark matter providing extra gravity. Everyone basically ignored him for 40 years. Mostly because he was abrasive, but also because invisible matter sounds like something a magician says when he drops his cards. Fast forward to the 1970s, enter Vera Rubin. She looked at individual spiral galaxies and noticed something even weirder. In our solar system, the planets furthest from the sun move the slowest. This makes sense. Gravity gets weaker with distance. But in galaxies, Rubin found that the stars at the very edge were moving just as fast as the stars near the center. It was as if the galaxy was a solid disk instead of a collection of objects. This shouldn't happen. By all rights, galaxies should be ripping themselves apart, unless there was a massive, invisible halo of stuff surrounding the galaxy, providing the extra gravitational glue to hold it all together. This isn't just a maybe. We've seen the evidence through something called gravitational lensing. Gravity bends light. When we look at distant galaxies, we sometimes see them distorted or magnified, as if there's a giant magnifying glass in the way. But when we look at what's causing the magnifying, there's nothing there. Or rather, nothing we can see. But it has mass. A lot of mass. So, what is it? Well, it's easier to start with what it isn't. First, it's not just dark clouds of normal matter. If it were made of atoms, the stuff we call baryonic matter, it would absorb or emit some kind of radiation. We'd see it silhouetted against stars or glowing in infrared. It doesn't do that. Second, it's not antimatter. When antimatter meets matter, they annihilate each other and produce massive amounts of gamma rays. Space is not currently one giant, continuous explosion, so that's a no on antimatter. Third, it's not black holes. While there are plenty of black holes, there aren't nearly enough of them to account for 27% of the universe. If there were, we'd be seeing gravitational microlensing events constantly, like a cosmic strobe light. Scientists have spent decades coming up with names for what this stuff could be. For a while, we had a face-off between machos and wimps. I'm not joking. Machos stand for massive, compact halo objects. These would be things like brown dwarfs or rogue planets. But again, we haven't found enough of them. Then we have wimps, weakly interacting massive particles. This is the leading theory. These are hypothetical particles that are heavy but pass through normal matter, like ghosts, through a wall. Right now, as you're watching this, trillions of dark matter particles are likely streaming through your body. You can't feel them. They don't bounce off your atoms. They don't have an electric charge. They don't interact with the electromagnetic spectrum. They don't reflect light, emit light, or even acknowledge that light exists. They only interact with the universe through gravity. Imagine trying to find a person in a dark room who doesn't make noise, doesn't have a scent, and you can't touch them, but every time they sit on the couch, the cushions sink. That's dark matter. We see the cushions sinking everywhere in the universe. We just can't find the person. Some scientists are looking for Ixion's tiny, ultralight particles. Others are looking at sterile neutrinos. We have built massive detectors deep underground, inside old gold mines, shielded by miles of rock to block out cosmic rays, just hoping that just one, dark matter particle will accidentally bump into a xenon atom and say hello. So far, silence. This leads some people to ask, what if we're wrong about gravity? This is a theory called MOND, Modified Newtonian Dynamics. It suggests that on a galactic scale, gravity just works differently than we thought. It's a bold idea, but most observations, especially the Bullet Cluster, where two clusters of galaxies collided and the mass seemed to separate from the gas, support the idea of a physical particle rather than just a math error. So why does this matter? Aside from the existential crisis of knowing you're a minority in your own universe, because without dark matter, the universe wouldn't exist. Not like this. In the early universe, normal matter was too hot and moving too fast to clump together. Dark matter acted as the gravitational scaffolding. It formed the wells that pulled in the hydrogen and helium, which eventually led to stars, then galaxies, then us. We are living in a house built by an invisible contractor. It's a bit humbling, isn't it? We spent thousands of years thinking we were the center of everything. Then we realized we're just one planet around one star in one galaxy. And now we realize that even the atoms we're made of are just a tiny fraction of the cosmic budget. We are the 5%, the visible frosting on a cake made of shadows. But that's the beauty of science. We don't know what the majority of the universe is, and that is the most exciting sentence a curious mind can hear. We're living in an era where the biggest discovery in human history could be just one underground sensiping away. If you enjoyed this deep dive into the invisible, make sure to hit that like button and subscribe to What Is. It helps the algorithm find us, even if we haven't found dark matter yet. Let us know in the comments what mystery you want us to tackle next. Are we living in a simulation? What's inside a black hole? Or why do we always lose one sock in the dryer? Thanks for watching, and keep looking up. There's more out there than meets the eye.